We are now going to perform a titration experiment in which we are going to determine the volume of one of the reactants to reach the equivalence point. So we're going to go ahead and calculate the volume of a 2.25 molar phosphoric acid required. What is the volume required to fully react with a 45 milliliter solution of a 0.150 molar of magnesium hydroxide? All right, so the first thing that we would do is write down the chemical reaction as in any stoichiometric type problem and write down the information that we have on each of the reactants or products involved in it. So we're going to go ahead and this would be our reaction. This is a balanced chemical sentence in which we have phosphoric acid reacting with magnesium hydroxide. So in performing the let's write down the information. In performing this titration, we have a 2.25 molar of phosphoric acid, and we want to react it with the magnesium hydroxide. We want to identify the volume required of the phosphoric acid to reach the equivalence point, in which we have a 0.15 molar magnesium hydroxide, and we have 45 milliliters of the solution. So like any stoichiometric problem, we need to go into moles and moles. And in this case, we're going to determine the moles of magnesium hydroxide, then determine the moles of the phosphoric acid that we need, and identify the volume. So what we have is we have two beakers, if we're going to kind of draw this out, in which one of them we have the phosphoric acid, and the other one we have the magnesium hydroxide. And we want to identify, in the case of the phosphoric acid, we have 2.25 molar of it. And in the case of magnesium hydroxide, we have the 0.15 molar, and we have 45 milliliters of it. And we want to find out how much of the phosphoric acid do we need to add to reach the equivalence point. So that would be moles to moles up into volume. All right, when it comes to determining the moles of an aqueous solution, we know that the moles of an aqueous solution equals its molarity multiplied by its volume in liters. So that's taking these aqueous solutions and how we identify the relative moles. So let's go ahead and start with the reaction, and we're going to go ahead and go into the moles of the magnesium hydroxide that we have. So the moles of the magnesium hydroxide equals the 0.15 molar multiplied by its volume in liters. We had 45 milliliters, so it would be 0.045 liters. Therefore, the moles of the magnesium hydroxide is 6.75 times 10 to the minus 3 moles. So we have 6.75 times 10 to the minus 3. And then we're going to go ahead and identify, based on that, how many moles of the phosphoric acid do we need to reach the equivalence point. So one could write down as a conversion factor, we see we have a 2 to 3 ratio of phosphoric acid to the magnesium hydroxide. We can write that down as a conversion factor and then use it. So we're going to go ahead and say 2 moles of the phosphoric acid requires 3 moles of the magnesium hydroxide. So we're going to identify, therefore, the moles of the phosphoric acid equals, well, how many moles of the magnesium hydroxide do we have? We have 6.75 times 10 to the minus 3 moles. Let's go ahead and write down what it is, the magnesium hydroxide, place it over 1, and now use our 2 to 3 ratio. 2 moles of the phosphoric acid for 3 moles of the magnesium hydroxide. All right, so magnesium hydroxide cancels out, and the moles of the phosphoric acid that we need to reach the equivalence point equals 0.0045 moles. Okay, so let's go ahead, and we have this amount of moles of the magnesium hydroxide, and now it will require 0.0045 moles of the phosphoric acid. All right, let's kind of clean that up and use that information. So we have come down and identified the moles of magnesium hydroxide, and that was 6.75 times 10 to the minus 3. And the moles to the equivalence point of the phosphoric acid equals 0.0045 moles. When it comes to phosphoric acid, we wanted to identify the volume required in which the molarity of the phosphoric acid equals 2.25 molar. All right, so to reach our final answer, once again, we want to recall that relationship in which the moles of an aqueous solution equals the molarity multiplied by its volume in liters. So we can come and then say what we want is the volume here in this relationship. So the volume will equal the moles divided by the molarity. All right, so the volume will equal 0.0045 moles, and divide that by the molarity of the phosphoric acid, which was 2.25 molar, equals, that value will equal 0.002 liters. And if we want to re-express it into to milliliters, we'll shift the decimal over to the right 3 places, and our final answer in milliliters will equal 2.0 milliliters. That's the amount that will take to reach the equivalence point.